First of all, welcome everyone. I hope you can see my slide. If you can just give me a nod. Okay, perfect. So welcome everyone to the Drone Interest Group, the deep dive, the second one that we have. And it is an honor that on this deep dive, we're going to cover a GSMA Foundry project, which is called the 5G Autonomous Drone. And this is a collaboration with Telefonica and Unmanned Life. Hence, we have as a guest speaker, David Mora Fernandez from Telefonica, which is the head of service and platform in Telefonica. And we have King McClement, which is the CTO of Unmanned Life. So it's a pleasure to have you both on this session. And we will go through what we did in a Foundry. They will share their own experience, the learnings, and please, as we go, you're welcome to ask any questions. So here I have a very high level agenda. Most likely we're not going to be covering everything, we will be shorter than 2 hours, but in case we are split it into half and you can ask all the questions that you want. So we will give the time for all your questions. As a little bit of housekeeping, because there are maybe quite a few, I would prefer if we can go through the presentation first. And if you have any question, do not forget the question. Please type it in the chat so that we take all the question then at the end of the presentations. And we will go through all your questions. So it would be easy also for the presenters to read the questions when they finish to present and then maybe already answer to you on the chat. So I will ask you please to all send your questions in the chat. And when we are at the end, if there are more questions, then please feel free to raise your hand and we give it the floor. As we going through, I would appreciate if you, just for simplicity, if only the speakers have the camera on, and all of you, if you could switch off the video and the audio, so we don't have any interference. Well, with this, let's kickstart the session. I will give a little bit of introduction to GSMA, what we did with the Foundry, and then I give the floor to the speakers. So as most of you, or quite a few of you will know already, in GSMA we have a dedicated vertical area, we can say, is in the aviation where we call it advanced air mobility. And we have different activity. One is the Drone Interest Group, and the other one is they call the ACJ, Aerial Connectivity Joint Activity. The DIG is primarily consisted of all the GSMA members, and we are sharing the learning, like this one, of accelerating and understanding how we can use the cellular connectivity and all the services from the mobile operator to support drones in the ecosystem. With the SCJ is a cooperation with another organization, is a global UTM association, which is an association from the aviation side, from the new UTM world and the drone world. There we try to work together to understand what are the needs on the connectivity from their perspective and work together to make sure that we have the right information and guidance where needed, and also progress on describing how to use the connectivity. What we do, there's a lot of resources available, from case study, white papers, glossary guidelines, and also web talks like this one. So just to give an overview, and it's all available openly on our website. For this particular session, we're going to talk about a GSMA Foundry project, what it is, the Foundry. GSMA Foundry is a new way of working of GSMA, is a way of focusing on a particular, let's say, problem or challenge in the industry, in the telco industry, and is a way to work together with GSMA members, industry player, and to rapidly try to develop a real-world solution, which could be pre-commercial or in initial commercial trial phase. The reason we do this one, because we want to focus on effectively things that are useful for the industry. And we try to utilize the capabilities of GSMA to convene, engage, and unify the end-to-end connectivity ecosystem. So moving forward and accelerate adoption, like in this particular case, and sharing the learning of what others have been successfully doing. For this particular project, the autonomous drone project has been run in between the 21 and 22. So we just finalized as a GSMA Foundry project. It's been quite an interesting journey and it's quite good learning. You can find more information also on our website. There are videos. There are also videos interviews from MWC. It was demonstrated in MWC this year in February. And the team has also won a GSMA Foundry Excellence Award, which you can see here. So I'm not gonna talk about how they did it because we will have the two guest speakers to explain everything. But again, I wanted to showcase that it is a good way to utilize the Foundry to accelerate and work on specific issues. And you also have a visibility and we try to move forward the learnings that is useful for other MNOs to understand if it's applicable for them, how to move it forward. They also published the 2 case study that we're gonna see now. So I just put it here. They're available on our website. One is called Rising Connectivity Challenge, which is for indoor case. We will learn all about it. And the other one is the Digitalizing the Skies for the outdoor case. So you're all welcome to read the case study. As I said, they are available publicly on the website. But with this, I want to give then the floor to the first guest speaker. So David, over to you. I presume you can also maybe take the control of the slide if you want to, or otherwise tell me if you want to go to the next slide and then I'll do it for you.
Okay, I cannot see the control for the slides right now, so I may be asking you if you don't mind because I cannot find it now.
Let me see if I can give it, but just go.
Okay, thanks. So as Barbara has introduced me, this is David Moro. I'm responsible for service platforms in CTIO in Telefonica, which basically means the network side of the equation here. So my intention is to provide some information around the challenges and the lesson learned that we have in these 2 Foundry projects with those 2 use cases on implementing the solution over our network, right? So that will be the perspective that I'm going to take in these slides, and most likely Kim will provide a complementary vision on the product and the drone aspects more related to the robotics, etc. Right? So yeah. The contents for my presentation in the next slide, you would see that I would like to first set the scene with the, sorry, I cannot, okay, thanks. So we'd like to set a little bit the scene with the background and the context, and also explain a little bit on the scenario from the operator perspective that we had for implementing these use cases. Also, I'd like to walk you through which are the challenges that we faced while deploying the solution on our cellular and edge platforms, and which is the architecture for the solution, the lessons learned, and how do we see that we could enhance the support for drones and drone orchestration in the future with some network evolution aspects. So starting with the context, we started this in the next slide, please. Next one. Thank you. So we started this with a trial that we ran. Sorry, there's a typo. Sorry, my fault. There's a typo in the years, so disregard the years. In 2020, we started a number of trials in the context of GSMA Telco Edge, and one of the trials that we partnered with BT was to demonstrate the capabilities of aggregate applications on top of our edge. So the idea was to deploy the same solution in an aggregated footprint, joining forces with BT in UK and Telefonica in Spain. And for that, we partnered with Unmanned Life to deploy their platform on our telco edge nodes. And for this, we have modeled use case on safe and rescue. Right, this was a very, let's say, punctual milestone that we achieved together, and it was a success. And due to that, we were proposing 2021 to continue this cooperation as a GSMA Foundry project, as Barbara explained. In our particular case in Telefonica, in the same time frame, we were working on several use cases to demonstrate the capabilities of 5G. And this is what we called, in our case, the 5G Use Case Lab, which is an initiative where we are cooperating with a number of partners, most of them startups from our wider hub, to demonstrate use cases that could be productized later as products. So for this, we decided to continue the Foundry project and the cooperation with Unmanned Life. And maybe if we can move to the next slide. Yeah. So for this cooperation, our objective was to deploy the Unmanned Life drone orchestration platform, the Autonomy as a Service product, in our network and using our edge. In this wider 5G lab, that use case lab that we have in Telefonica in Spain, we are normally providing the partners with capabilities from the network as a service vision. At the time that we started these trials, we had connectivity, 5G connectivity, and we have edge, the telco edge, as per the work that we are doing in GSMA, telco edge cloud, and OP operator platform. So the idea was to deploy the platform and have permanent demonstrators in our HQ in Madrid, in Distrito Telefónica. So those demonstrators or demo kits could be easily driven by non-experts in either drones or pilots or robotics or anything, just to be able to have this in order to showcase use cases to potential customers and institutions, and also for the internal stakeholders. Um, for that, we selected and focused on two use cases. One focused on the outdoor scenario and one focused on the indoor scenario. For the indoor scenario, we selected this warehouse management in an industry ambient. You can see the picture of the environment where we set this use case. And for the outdoor scenario, as you know, we have chosen a surveillance use case together with our business, with Telefonica Security Engineering. And we were thinking to evolve also the outdoors demo kit to another use case based on the critical infrastructure inspection. In this case, you may imagine in our campus, in our headquarters in Telefonica, as you see in the picture, we have all the ceiling with solar panels. So we are thinking about this use case to evolve the outdoors demo kit, to use drones for inspecting the solar panels in this case, right? So moving to the next slide, setting the objective, maybe I can say a few words about the operator scenario that we have here, right, for these demo kits. So as mentioned, for the indoor scenario, we have our demo center in our headquarters. This is mostly oriented to B2B customers. So our idea is to have, as I said before, a permanent demonstration so we could show our visitors, mainly B2B customers or government or public authorities and institutions, how we could operate this kind of products. Of course, there will be here some challenges that I will be explaining a little bit more detail later. But basically, as you may imagine, for the demo center indoors, we need to cover the area with enough coverage. And in the case of outdoors, we were also setting the expectation to use drones in our campus, meaning basically that these drones should be connected by 5G using the cellular connectivity outdoors. In the 5G use case lab that we have in this scenario, it has been always very important for us to provide to the partners, to the startups, or to the application providers, in this case, Unmanned Life, with those capabilities in our commercial network, meaning that we are not using lab environments, we are not using test beds, we are using either pre-commercial capabilities in production or directly the commercial services. Why? Because the effort that we are doing, we want it to be against something that is going to be almost the same that we are going to have when commercializing and exploiting the products. So maybe it is not useful to run trial or a use case like this in a test lab. and using, for instance, 5G connectivity in test lab, and then moving to the real environment and face a lot of problems. So these use cases are exactly here to investigate and raise which will be the challenges and the issues that we may be facing in a real environment, right? Or in a semi-real environment. Yeah, and as you see, we are using then the commercial 4G and 5G NSA network, mainly for those two use cases, both indoors and outdoors. We were using the public network, and we were also preparing to use 5GSA technology also in a commercial network limited pilot, but this is yet a work in progress. In the next slide, please, we could also talk a little bit about the requirements from the perspective of the application provider. In this case, specifically, the requirements that Unmanned Life post to us as network operators in our platforms to be able to deploy this kind of use cases. Well, maybe Kim will explain this later, but in a very simplistic way, the solution has two main components. It has the mission control and it has the video analytic part, right? For instance, this video analytic is combined with the mission control in order to implement certain aspects of the use cases. For the indoors use case where we have this stock management, we are going to use the video analytics to recognize those elements from the stock that needs to be identified, counted, etc. And from the surveillance use case, we are using the computer vision to identify objects, for instance, the people that are in our campus, right? Yeah, so the requirements that were posed from Unmanned Life, of course, and from any other application, I guess, in this vertical using drones, are much related to the specific use case. There are use cases more stringent, and there are use cases that are a little bit more relaxed in that direction. So if we take a look to latency and throughput, latency, the indication that we got is 20 milliseconds will be perfect, but depending on the use case, of course, 50 to 60 milliseconds will be valid, and even higher if needed. And also throughput here is quite important for the video streams that we are using from the drone camera for the computer vision part that I mentioned, right? In this case, we got an indication of having 30 megabits per second will be ideal to avoid, well, buffering in this case. We chosen not the most strict use cases because, as I mentioned before, the objective in the 5G use case lab is to demonstrate things that can be happening in a real environment and also could be pre-productized, right? So, for instance, lower latency will be strictly needed when doing complex tasks, but this is maybe something that we are investigating further, and we decided to start with those two use cases where we have the possibility of have medium requirements, right? So low latency in this case, in the use cases that we chosen, is required for the mission control, especially, for instance, to react immediate to certain commands, like, for instance, a kill switch or abort mission. And also, it's quite important when remotely, in the case of the surveillance use case, for instance, the teleoperator needs to move the orientation of the camera. So if we want to have a good experience, we need to have a low latency. And well, as you may imagine, the throughput is quite important if you want to enhance the end user experience. For instance, in the surveillance use case, if there's a human operator watching the video, it needs to be without any freezes or buffering that is unnecessary. And also, when we are using a computer vision or video analytics engine, it's quite important that the video is received correctly in order to have a correct identification, right? If we go further, maybe to the next. Yeah, which are the challenges when deploying this solution in an operator network? Well, the way that we see this, I mean, there's I don't know how to explain it. It's a different vision on the connectivity designs that we need in this kind of solutions, right? So robotics normally require to have peer-to-peer connectivity with the orchestration platform, while our networks are designed mainly, or were designed mainly, to be able to provide an efficient communication for accessing to the IP network, massively internet, but normally they are following a different paradigm, right? As you know, so we have the APNs, we have the firewalls, we have private addressing spaces that then are turned into public with the GNATs, etc. So there's like a confrontation between the designs, and it needs to be somehow coupled. And this was really one of the major challenges, especially because the solution that we want to provide with the drone automation over 5G needs to work over any kind of 5G connectivity or cellular connectivity, meaning that we are not designing this specifically for, I don't know, a virtual private network or a private network, or, I mean, it needs to work with any situation of the connectivity. If we think about our B2B customer where we are selling this solution, it needs to somehow adapt to a variety of scenarios that could demand or could be matching this demand, right? Another big challenge is that we discover is the aerial and indoors coverage. The aerial coverage, of course, is, as you may imagine, because when we plan the radio access, we normally are thinking about terrestrial usage. And initially, when we design our network, we are thinking about this kind of usage. So we discovered that, yes, we have air coverage for our 5G and 4G networks, but this is not totally optimized, especially we have high demands like video streaming, right? So this was something to be tackled. Another big important thing is the indoor localization. So drones are basically using the GPS or GNSS signals to position themselves, and this is critical. So we cannot use, let's say, default of the self drones without any improvement. And this was something that Unmanned Life, I guess that Tim will explain later, but needed to work to be able to work in environments like the indoors use case, where we don't necessarily have a indoors GPS signal. So we need to rely on other solutions in order to be able to ensure that the drones are able to localize themselves correctly, especially in such a limited environment. I mean, a warehouse is normally bigger, but our demo center is not a warehouse, it's really a small space. So the challenge was even higher, posing a strict requirement on that direction to Unmanned Life and our solution. Another important thing is that we are using video processing, and we are not relying on any element to do so except for the edge capabilities. So this means automatically that our edge capabilities, either public network edge or on-site device edge, needs to have GPUs, graphical processing units. And finally, and also quite important, is that we wanted this not only to be a demo that we do for a client or a customer, but something that can be run continuously. We have a lot of visits in our B2B demo center. We have a lot of customers that were interested in this solution, and it means that the solution is running continuously. And maybe, well, we have, I don't know, from tens to hundreds of flights, some of them for testing, some of them just customer visits that were interested in understanding the solution, right? So this was important, and we needed to industrialize somehow the demo kits that we used together with Unmanned Life. Okay, maybe continuing, I will provide a small view on how it's looking the architecture and how we are working on it for both the 5G connectivity and the edge. So we have a slightly different architecture view depending on the use case for different reasons. So we decided to start with a simplified architecture for the first trials. So our interest was to have the indoors and outdoors solutions working as soon as possible using the 5G and cellular connectivity. So for instance, in the indoors use case at the left of the slide, we can see that the two main components that I mentioned earlier are split into two different edge solutions. For the mission control, we are using a simplified deployment over on-site edge device on campus. And for the analytics, we are using the public network telco edge in our network in Telefonica, right? Yeah, in order to minimize latency, in this example, for instance, the on-site edge device is using a fiber connection. It could use also 5G, but we wanted to reduce a little bit latency here, and the drones are using the 5G and cellular connectivity. In the outdoors demo kit, we are using the on-site edge devices for the two components. And if we see the next slide, we can see that we are working right now together with Unmanned in moving the components and optimizing them to be running on our public network telco edge. Of course, there are situations, there are deployments, and again, this depends a lot of customers' demands and customer situation and context, where we will need to deploy the solution on an on-site edge device. And there are other situations where, due to costs or due to, let's say, time to market, we would prefer and prioritize deploying on the public network edge. So again, for us as Telefonica, it's important that the solution that we are working is flexible and versatile enough in that direction. Okay, maybe moving further. So lessons learned. This is the important thing. We've been working for some months on the Foundry project with Unmanned, and we have several things that maybe are important, right? As I mentioned before, we want this solution to be carrier grade and be flexible enough to work in any condition for any connectivity scenario for the customer, right? That will be meaning that the most challenging scenario will be to use the public internet access, the so-called the public APN that we use, for instance, for cellular connectivity from smartphones. Of course, going down, there will be other solutions that are more optimized, maybe from the network perspective, to ease things to the upper layer, to the platform solution, like for instance, using static addressing. There are APNs in our networks that provide this kind of services. Also, we could use a private APN for IoT devices. In our case, well, it will be the Kite solution, if you have heard of, or directly in some scenarios, we may use in a private network directly on our customer premises, right? So yeah, there are differences in the solutions, but what we wanted to have is that the solution works over any connectivity condition. And of course, for network experts, you may know that the telco network is not a private network on premises, which is, I would say, maybe the simpler approach to deploy quickly. So there are configurations on and restrictions due to the firewalls that we are using internally, to the CGNATs, and this affects somehow the design of the solution. Especially important when, as I said at the beginning, the critical requirement is that the drones needs to have peer-to-peer connectivity with the platform, right? So we need to take a look on how is the MTU size, what are the ports that are being using, which is the IP addressing schemes that we are using, how the different components of the solution, the microservices communicate to each other, and all that has been important, and we have learned a lot together with Unmanned in that direction. Also, in the next slide, following with other lessons learned, yeah, we've noticed in our case, in our headquarters, that you saw in the picture that has this ceiling with the solar panels, the 5G coverage is somehow oriented mainly to the land. So we have noticed that when the drone takes off, the coverage and the signal strength could be different, could be variant, right? So we need to take this into consideration when designing the specific use case. And also the video needs to be optimized in accordance to the available throughput or bandwidth, and also ensuring this good quality of the image, both for the human eyes as well for the computer vision eyes. From the network perspective, well, yeah, I've given a hint about the low latency and high throughput requirements, but it is not that important that the latency maybe is so low, but it's more important that it's predictable or it's stable. And that applies almost to the main parameters of the QoS connection, let's say latency, throughput, or packet loss. And of course, as mentioned, right, in indoors case, if we don't have indoors GPS coverage, or its poor coverage, we need to improve the drone solution with enhanced elements for localization and collision avoidance. That was also a lesson. Finally, yeah, so as I mentioned, if we move to the last chapter, we were using in our lab the basic 5G cellular connectivity and the edge capabilities, right? But we see that there's still a long path with a lot of enhancements in the future that could be really useful for drone use cases. So the first one that we were immediately thinking is to use the QoS. And for that, we will be exposing the QoS management through APIs using our net from the 5G core element when available, or even to provide the status of the connectivity in order to provide this kind of visibility of the connection that is important through network DAF APIs, right? That will be an immediate step, maybe. And also another thing that we are thinking, of course, is to provide slicing services. That also a no-brainer. And as you know, well, we will be launching SA globally around this year and the next one, I hope, at least as industry. But the technology, new radio, needs to get improved in terms of providing the promise of the low latency, right? So we will be expecting here to have an improvement of the latency to get to the 1 millisecond promise in the following years, right? And also following a little bit our vision that we have been working in GSMA in Telco Edge Cloud. The Telco Edge Cloud will improve also deployments being more capillary. For instance, I think I saw a question there, but we have in our 5G use case lab, we are using 3 nodes in Spain to cover the geography, which is enough for the moment, but most likely we'll need to increase the capillarity. Also, specifically, if we want to address certain use cases where we don't need to have necessarily an on-site edge device and we want to use the public network. So we need to ensure that we have a closed edge node, in that case, in the public network. And also the telco edge concept that we have been working in GSMA and with our providers considers the possibility of having mobility support, which is also important, meaning basically that the loads, the applications that we deployed in the telco edge can also follow the movement of the in this case the UAV, right, the drone. Aerial radio planning, also it's important. That's something that we have been starting to discuss with our access colleagues. So the tools that we use for planning needs to consider that in the future we are going to have a lot of UAVs or drones or user equipment from the cellular network flying in the air. And in that direction, also from 3VP release 18, I think there's a lot of there's some items to improve the support of UAVs. And finally, an important thing that we need to start looking at as an industry is how we are going to be able to provide drone identification and e-vision when using 5G, right? If we are going to have in the future drones using beyond light of sight, it is clear that most of them are going to use this kind of connectivity solutions instead of radio frequency, right? So we need to be ensuring that we are able to provide services to regulators and public authorities, right? Well, and this is more or less what I wanted to describe. I think there are several questions on the chat. I don't know if this is the moment to take them or we should go to Kim presentation first.
Maybe it's best to have Kim first. You feel free to already answer on the chat if you want, but I will take them all at the end because I guess somebody will be answered directly by Kim. So Kim, I have 2 videos here. Do you want me to show the video first or you want to do the presentation? When do you want to see the video?
I had some indicators on 2 slides where it would be good that I go a little bit through the use case and then we look physically how it runs. That is not a problem, Barbara.
Absolutely not. Just let me know and I have to switch to the other window.
Yeah, a little bit more in context, and then it's also a good interruption of hearing me talk and then you see something instead than just listening to me. So
So you might be able actually to take the control, but feel free to ask me to go to the next slide, whatever it's easy for you.
Yeah, the request control is disabled on my side.
Okay, that just asked me to go to the next slide. Do it.
We'll do it like that. Yeah. So first of all, nice to meet you all here on this call. Appreciate your time, the time that you're making to come and listen about our experiences. I'm Kim Clement. I'm the CTO of Unmanned Life, as already introduced by Barbara. We are a software company that provides a software platform that enables individual robotic devices in general, not only drones, but also ground vehicles, amongst other devices, with different functionalities, capabilities, and functions to operate and work together as one workforce. A lot of the focus here in the presentation will be around drones, of course. I will also bring in, I think, a complete different viewing angle often than a telco viewing angle, because we are coming from a service perspective and a software and robotics perspective. And I think one of the conclusions that I will have at the end of the presentation is also exactly that, that we have learned throughout these collaborations and these partnerships that we are lacking from our view and from our understanding an important part, which is network knowledge. It's something that we also have addressed and are addressing within the company. That being said, we can go to the next slide. What I first introduced, what kind of problem that we are trying to overcome here in the ecosystem with our approach. That is that we see that a lot of robotics are being adopted. Again, ground robots as well as aerial robotics. As David said, in the future, a lot of drones will be deployed in the same airspace at the same time. But today, all these robotics are running on their own hardware stack, including with a software stack. So they are all silos operating next to each other. As a vertical itself, they will be fully functional, but then once they need to interact, there are challenges to overcome. Secondary, a lot of these devices are also working over a proprietary communication link. Either it's an industrial Wi-Fi or a 2.4 gigahertz proprietary Wi-Fi link for remote control of drones. That's also one of the problems we are trying to address in these collaborations with our telco partners, and specifically here with Telefonica. So we are addressing that fragmentation. Yeah, we are doing that via the next slide. We are doing that with an approach where we have one centralized platform that both orchestrates, controls, and deploys these autonomous robotics. Of course, that's a layered approach, but maybe first on our let's say solution architecture on the next slide. So if you look at the solutions architecture, we take on the left-hand side what we call off-the-shelf robotic devices. Yeah, these are not changed or not augmented with anything. What we do is we leverage the existing control mechanisms or the drivers that are already on board. And in the case of drones, that's very important because that means that we are installing our software on top of the existing flight control unit on the drone. That means that we still maintain the safety mechanisms that are by natively built in the drone. All the fail-safe mechanisms are still operational. We are not changing those, we are not altering those, we're not removing them, we are just sitting on top of them. That also means that we are adding on a safety layer, actually two safety layers and two safety mechanisms on top of the existing one, which is also important towards the future for regulations and scalability. Now, what do we do exactly on the device? We install over there what we call our autonomous control end node. Yeah, it's a software package that we have created from scratch. And that software package takes care of two parts. One is the integration with the device. I saw one of the questions. So yes, indeed, it takes care of the C2 communication, so control and command of the device, but secondary also the data collection of the device, either from the native sensors that are already installed on board, or either from additional sensors that can be installed on top of the device. This is also very important because our platform allows to install additional sensors that are not plug and play for an off-the-shelf robotic device. So it means you can really create a tool, which for us, these robotic devices are tools, and convert that tool to a useful device that you can use for your use case. So you enable use cases in that way. Secondary, the software also takes care of that integration with the network layer. So that's where we are opening up to different types of networks, which in this case, we will be discussing later on, and also David has been discussing already, also include some challenges over there. Very important, we deploy this application as a Docker. Yeah, so it sits on top of the device as a Docker, as a container. And we can either deploy it on the existing computational power, which in one of the use cases we are discussing today, we have done with the indoor use case, or we install as an additional companion computer with the Docker on top of it, which is then the other use case, the surveillance use case, is a use case where we have done that. It purely depends whether there's computational power available or not, and if the provider or the supplier of that computational power is also okay with running our applications next to their applications on top of the device. If not, we just extend it with a companion computer. So then we leverage the wireless network. We are compatible with various networks, and we can even, let's say, operate with different devices connected over a different network. But of course, the capabilities and the features that you can enable for the use case will depend on the quality of service that you have on the network. We come back to that in a minute. Now we do centralize all the data to a central control platform. And I saw also one of the questions, where is that platform deployed? So as you just heard, a part of the platform is on each single device. Basically, it's a system of system approach where each device is integrated with our system of systems via that integration point, which is the ULAs. But then the orchestrator and the central control platform is deployed on, in this case, together with Telefonica, on an edge infrastructure, on the campus of Telefonica. The application could be deployed on other locations. It could be a cloud deployment. It could be an on-premises deployment. It's also a container. It's also a Docker. So there is flexibility, but we know out of experience that the closer we can run on site or near deployment, the closer we can run, the better it is for the quality of service as well as the latency. On-premises is a good solution, but then a less scalable solution. If you have a dedicated server, that's where, again, edge computing and cloud computing allow us also with more scalability towards the future. There's 4 important pillars that we take care of in the central control platform on our side. One is the device management. We manage the devices, their characteristics, capabilities, battery statuses, alarms, and so on. Secondary, we are also doing the data management, meaning the data that we collect from the devices in the field to create a context, to drive our solutions, but also to pass it through to third-party platforms, as well passing through as receiving data, because we also integrate via the portal with business information systems, with legacy information or warehouse management systems, for example. Also UTM platforms. We have an API, UTM API, where we can provide them with the telemetry data, but much more, also flight plans. We can receive flight permits or flight approvals, and we can also receive dynamic geofencing and alarming from UTM platforms, which will also be important towards scalability in the future. And third-party sensor solutions, as already mentioned. I'll come back to the sensor solutions. I know there was a question about localization indoors. I have a slide on that as an introduction of our first trials we have done, where I will touch upon that topic. Now, the 2 layers that I just discussed are what I call the fundamentals of our platform. On top of that, you have the real use case enablers, which is on one part the mission management or the orchestration layer. That really takes care of the end-to-end solution. It's where the modules are being put together that really enable these devices to collaborate for a common goal and task. And to drive this mission management, we are leveraging decision making. So we have a decision management layer over there, and that can either be very trivial with inputs from alarms, which are just flags we receive that will trigger events. But it can also be more intelligent, where we leverage, for example, AI and machine learning for object recognition, where we can do anomaly detection. And typically we work together with third-party expert platforms for these kind of use cases. We provide them data set and they provide us the insights. However, within these trials, we have worked on in-house algorithms that we have augmented and tailored for the specific usage within these trials and demonstrations. Combining all these blocks, we can enable different use cases in different industries. Today, we have, let's say, more a focus on smart cities and Industry 4.0. Now, based on that introduction, maybe I translated a little bit to layers in the next slide of where these layers sit, and then I can go into the use cases and how we have enabled them. So there are a few layers over here that we are implementing from our point of view. So if you look at the ULA side of things, if you look at that module, what does it take care of? As mentioned, it integrates the device. It integrates with that logic device control on top of the device. So we buy these off-the-shelf hardwares, and then we integrate with the wireless network. Then over the network, we have the ULCCP deployed on an edge infrastructure or on premises. In these kind of deployments, we are taking care of that device management, data management, mission management, and decision management. That takes care in the ULCCP. And then we have a portal to the outside world. I call it the window to the outside world, and that can be twofold. One is APIs. We have APIs that expose to business information systems and third-party expert platforms. We are quite flexible over there. We are taking, let's say, the customization on our side to create wrappers and APIs to expose that to third parties, because we know that not all the customers have that flexibility. And secondary, we are also providing a user interface and some variations on that, which you will see throughout some of the videos later on. Now, if you go to the next slide, if you translate that of how you enable a use case, this is now, let's say, the main building blocks towards the surveillance use case. And the other ones are similar, how they are constructed. So on the bottom, you can see one of the drones used for the surveillance use case, which are DJI drones in this case. They come with an OSDK, so it's an SDK that allows us to integrate with the DJI device, as well as a PSDK, which allows us to integrate with the payload of the device. These two SDKs allow us to control and command the drone, collect the sensor data, but also control and command the gimbal and control and command the pan, tilt, and zoom of the camera that is installed underneath the drone. Now, on top of that drone, as you can see, there is a small box that is a companion computer that we have provided here within these collaborations. And on top of that companion computer, we run our ULA's software. So the software is located there. There is then serial communication between the drone and that companion computer, and we also get the power supply from the drone itself. And on top of this drone, and this is one of the challenges that we had throughout the whole journey, and which I will come back in a minute, we also have a modem installed. Of course, we have different possibilities to install these modems, and there it's a combination of what is available on the market, what is technically available at a certain point in time, and then once technology is available, to adopt it and implement it and make it compatible with the system. Today we are using integrated modems over there that are part of the companion computer, but we have gone through phases where we are using ZXL MIMOs to do the connectivity with a final backhaul with an Ethernet connectivity or a Wi-Fi backhaul. And before that, we even had to use smartphones because there was nothing else available except big CPUs on the market. Now, centralized, you still have that control platform. And then, as you can see, we have some use case enablers. In this case, it's object recognition for the surveillance use case, which is also running on the edge infrastructure. And then secondary, you have your web interface. We are using a web-based user interface, which is easily accessible as long as you're part of our authentication, or if your system is authenticated within our setup. We can go to the next slide. So here, this is the first use case I want to touch upon. It's not part of, let's say, the Foundry, but I think it is really, and I saw David also refer to it, because it's really where the foundations were laid in our collaborations, and where also the trigger was made on. This is a very interesting collaboration. Yeah, we as a startup company also, and as a software company, we don't always have access and availability to use these high quality networks, new technologies as 5G edge computing. And these collaborations and partnerships, I think, with a service provider as us, as well as a telco expert, is really valuable. We learn on both sides. It's not always easy learning because we sometimes speak a different language, but also there we have learned to talk each other's language and to understand each other and to learn and adopt. And the start was a search and rescue demonstration we have done before really the GSMA Foundry. Maybe if we go to the next slide, I'm just going to quickly walk you through that. Yeah, we tried to set up over there an indoor demonstration kit, and you see a bit of a mock-up over here of how it looks like. It was 2 smaller drones we used that were installed with a whole bunch of cameras and sensors. So even the hardware on the drone side was not really mature yet at that stage, I would say. And we used a mock-up person on the floor to detect. So we had a search drone that was detecting that. And we had then a rescue drone that was flying in a mock-up life jacket. It contained all the building blocks over here, but we had a lot of challenges still to face. At that time, we were still using smartphones as a modem in between, where we had to deal already with some first handshaking between 4G, 5G. So we tried to lock that in. That was one of the first key learnings. And then localization-wise, which was one of the questions, so I'll tackle it and take some time of the Q&A here. One of the challenges was to localize these drones in-house. So our first steps over there was we'll provide an absolute reference system. We create our own satellite system over here indoors with ultra wideband and reference points and beacons. Now that worked. There's no issues on that. But you have a lot of dependency, let's say, on that absolute positioning system, which we try to augment with some optical flow. But the challenge is also that it requires quite some time in preparation, setup, testing, and you can make mistakes also with that testing. So it's something that we discussed also with Telefonica to see how can we optimize this? How can we make this more flexible, easier to deploy? And something that we took as homework to work on. And we are still working on to improve that throughout time. So you will see another setup, which I will show later on for our inventory management solution, where we are not using absolute reference beacons anymore. We have other, let's say, redundant solutions we have implemented, and also other solutions we have tested to overcome that. As mentioned by David, this was also a collaboration together with BT. So here we also try to deploy the same use case in 2 geographical locations, and also on 2 different carriers, but for the same use case as if it was the same customer deploying it. So we tested over there how smooth the onboarding was of the applications on the edge infrastructure, how easy it was to replicate, and we also measured some KPIs over there and differences between latencies, deploying it locally, deploying it over from a different country, et cetera, et cetera. So this was the groundworks. And we noticed over there as a service company, as a service provider, that we had a lot of work to still overcome to go to commercial stages. And that brought us maybe some more insights on the next slide on the setup, but I'll keep it brief for this one. Which is the end-to-end flow. We have deployed this also in more commercial scales now today, also on public networks in different areas. More than happy to give details on that. There's videos online publicly. I'm not going to go deeper in detail on this. Feel free to look it up and look into the videos. You can find these on YouTube and other challenge for our website. You can go to the next slide, Barbara. But that brings us to the current use cases that we have been deploying in the Foundry. So the first one that I will touch upon is the surveillance use case. So if we go to the next slide, here we deployed it with DJI M300 drones, which is, I would say, the state-of-art device that is on the market today. If you look in the drone ecosystem, there is a newer device now, the M30, but it's not such a workhorse. It's smaller in size, has less capabilities to fly in weather conditions, wind, and so on. So I would say that this is industrially the workhorse of DJI today. We have worked on this together with Telefonica. It was also for us the first time working with these devices. So also over there was a bit of a learning curve. And what we have taken is a drone with a 4K camera. We installed these with emergency parachutes, which is also very important for one of the challenges we're still facing, which is legislation. I'll come back to that briefly later on. We have some localization systems as well as 360-degree obstacle detection on board of the drone with stereo cameras. And on top of that, we have augmented it with our companion computer, which is the blue box on top, which also takes care of the wireless communication. As mentioned by David, we are using over here a commercial network. It's not a testbed, it's a commercial network, and a lot of key learnings come out of using a commercial network also. We deploy on different networks with different partners, so we have a good comparison over there, which I will also touch upon in a second. Next slide, please. Now, for the area itself, the campus, we discussed it with Telefonica. First of all, I want to state, legislation-wise, this is a very challenging location to fly in. Yeah, it's not only network side of things, but if we look to make things commercial, everything will play a role in that, and we all need to learn from that. So legislation-wise, the campus, it houses, and correct me if I'm wrong, David, but it houses about 20,000 people in the first place, and it's an open campus. There are shops in there. They have Starbucks, electrical shop, or electronic shops. So people can roam in and out freely in the campus. Of course, there's security on the campus, but there's no bird's eye view yet. So what we have done over here is install these true autonomous drones to augment the security rounds with a bird's eye view of the campus. Now, this campus is also located next to a highway, and in Madrid, and then the capital, and then next to an airport, or there's an airport close by. So you combine these all, that's actually the worst case scenario today to request for flight permits. And there also, again, we joined forces, and Telefonica really took, let's say, the front lead in that too, as the end user of the solution, to really talk and discuss and negotiate together with the legislation to get all the flight permits and waivers in place to deploy these solutions. This is very important because this is pioneering work that we are trying to do, which is very labor intensive in the preparations, but allow us now to deploy this together with Telefonica, get the key learnings out of that, and also share the insights with the legislation bodies. So they can learn from this too and adapt their regulations towards the future to make this more open and more scalable. We have split up for now the campus in two areas. So we have a north area and a south area where the drones will be patrolling over, so that today they are still staying above the buildings. That also allows the people on the ground to get acquainted with some drones that are in the air, but they are not immediately flying above them. So it's, let's say, an introduction to these devices are around, they get familiar with it, and then in the future we can extend that, also based on the experiences that we get. How reliable, robust is this? How much dependency do we have on environmental, network conditions, and hardware and software conditions? Now, if we go to the next slide, This is a bit of a mock-up, but I think it's maybe better that we play the video of the surveillance over here, Barbara. It's about 1.5 minutes, maybe a quick walkthrough of how it looks like in the field.
Switching now to the, just a second, I'm switching to the video.
Perfect, thank you. I hope it's smooth enough to see. So as you can see, it was referring to TUS. It's a collaboration we have together with Telefonica, with the TIS department over there, where we're providing Telefonica unmanned security systems. So the drone solutions are a part of these systems. You can see here the split up of the west and east wing of the campus, and they are surveying the area in the center. Here you see the 2 drones taking off. Yeah, that is orchestrated by the central control platform. They will go to their loiter altitude, and then they will each get their mission to orchestrate above the campus. There is the possibility also to select an ad hoc area, yeah, where the drones will define their own paths within that area, and that will fly within that area. But again, as mentioned here, to make the people familiar with the solutions in the field, we have now have dedicated flight paths above the rooftops of the Telefonica building. Here you can see an overview of the user interface. So you can see the drones flying on one side above the map, and on the other side you see the video, picture-in-picture in the interface, where you can see the augmented or the overlay where humans are detected in the field. Here we are using an open source algorithm that we have augmented and changed and adapted for this purpose, which is running as a third-party expert platform that we integrate with. So it's a separate module we install in the infrastructure here, which is called ULVA. It's our video analytics module. And during the flight, the operator has continuous control and command also over the gimbal, pan, tilt, and zoom, so they can adjust the areas of interest that they are looking for. Okay, that concludes some let's say, insights of how it looks and feels on site. So we can switch back to the presentation. Barbara, sorry for the switching. We'll have to do that one more time later on.
Yeah, over to you.
Perfect. That brings me to the second use case on the next slide, which is the inventory management use case. That's an indoor use case. So outdoors, we have the benefit to leverage localization or GPS localization was also one of the questions. The localization is very important. The good thing is outdoors, and especially with the hardware that is on the market now, there's triple redundancy of flight computers on board. There's triple redundancy on GPS, and these devices are even RTK enabled and capable. So even if you install a base station, you can get a correction, and you can get centimeter accurate localization, as well as Z, X, and Y. Today, it's not even running with RTK, and I would say that these drones are flying with an accuracy, sometimes depending on weather conditions, of about, I would say, 1 to 2 meters accurate in their space from takeoff to landing. That's the area where you will be landing in. Now, the inventory management use case was a bit of a use case where we wanted to see how we could showcase the same building blocks as the outdoor use cases, but then in an indoor, quite confined environment. We built a solution from scratch in collaboration with Telefonica and with the purpose to demonstrate this to their customers. So we used a different type of hardware here, which is called Model AI drones. It's a spin-off of Qualcomm. They have a company that is building drones using Qualcomm chipsets and an open source flight controller. So here we are using a Mavlink protocol to communicate with the drone. We have a hardware abstraction layer that can switch between DJI and these open source devices. And we have, again, a central control platform that is orchestrating and navigating the drone throughout the flight. The challenge over here, as mentioned, we are not using absolute reference systems anymore. We are purely supporting onboard cameras of the drone. One, to collect the data, which are barcodes in this case. So we are scanning barcodes of the objects on the shelf and then populating these objects on the interface. But secondary, we are also using these cameras for the localization. It's a combination of VIO, optical flow. We even have tried and looked into using some visual markers on the ground to even augment the solution. And one of the first struggles that we had was technically, because there was a lot of new technical features that we have implemented. So also on our side, it was not only overcoming edge integration, it was not only overcoming integration with network, but also ensuring that the technology itself, which was state of art and new, that was working as needed. We had issues in the beginning on localization, the accuracy, precision, and the reliability on that. And then it becomes quite challenging. That's where I say the communication between a telco and a robotics company can be quite different. And you also want to put your finger on the correct root cause. Yeah. So I think that was one of the big challenges we had too, is we identified that something goes wrong. And then it's questioning, is it a software issue? Is it a sensor issue or an environmental issue? Or is it a network or edge infrastructure issue? So suddenly you have a lot of variables over there of all technologies that are still evolving. And I need to say over here, and I want to identify that collaborations with Telefonica was always with a full understanding, with an open mind also of looking into it, but still challenging each other on, okay, where is the problem? Can we look into it? Can we set up workshops? So we have done a lot of workshops. We have done a lot of testing together to get on top of these problems. And of course, a majority of that was also on the software side because it was new. So we did optimize that. We increased or changed sensors on board of the device. We even changed devices. We have been looking into different devices over there because Model AI has now a full 5G enabled drone end-to-end that comes with a 5G module embedded on the device, while here we were still using a ZXL MIMO for that. The device is almost ready for deployment now. We're doing some final testing on that, but these are also key learnings. Having embedded equipment is always much more robust, reliable, and has less overhead and management at the end when you deploy it. So these are still improvements that we are trying to do. Now, if you go to the next slide. Some of the features and capabilities that we enabled over here, as mentioned, we tried to squeeze it in an indoor demo kit, but we wanted to show the network integration, and the benefits of that network integration. We wanted to show that we can orchestrate autonomous drones, although it's not a swarm over here, it's a complex and dense environment that we are doing it in. We're doing real-time video streaming over here. We're doing then an augmentation layer on top for the detection of these barcodes, and then using these detections to populate it on the user interface. And then finally, we optimized and improved our functionality around our indoor localization. Now, going to the next slide. I think again here, instead of going through the interfaces here, I think we can quickly run through the video. It's again about 1 minute. And then I'll go to the conclusions and the key learnings of our collaboration. So the setup here, very important, as we are not using absolute reference systems anymore, it fits into one fly case that can be carried on. The drone comes with its cameras, with its onboard sensors, with the remote control for emergency usage if needed, spare parts, batteries, everything is in one fly case, even the charger. So it makes it very mobile and very transportable. There are still some dependencies, of course, of lighting in the environment and floor and references in the environment, which we also learned in deploying over there. So if you have a lot of repetition in an environment, it's very difficult for the system to use video odometry or visual odometry to localize. And secondary, of course, if there is no light, also the cameras have limitations on functionality. So also over there, we are looking in the future what we can improve to optimize that. So you can see over here a little bit of a glimpse, which we could also see in David's image and picture of the area. We are located, let's say, in a corner next to some other demonstrations that are running. We have augmented the drones here with a camera, a frontal camera, which we also try to tweak and change to optimize the distance that we can fly from the racks. The first cameras, as mentioned, we had some, let's say, improvements we had to make on the localization, but secondary also, we made some improvements on the camera so that we could fly a little bit further away from the rack. So we tackled actually two problems at once over there. Now, this warehouse solutions over here for us, it's, let's say, a demo setup that we have today. It's something that is not fully rolled out as a commercial platform. It's not our main focus today. But it's something that we could look into in the near future with reliable networks, proper localization, and our software platform, we can optimize that. You can see here on the left, the drone flying in front of the boxes. So we have installed QR markers for now because that was easy for us to create a solution around that. Of course, in the future, you can have already native solutions, barcode scanners, OCR systems that can be installed on the drone. Again, it's a use case enabler. For us, it doesn't matter so much what the payload is on the drone. It's more about the orchestration on our side, end-to-end, and the integration. Then we go back to the presentation. So I will go to the key benefits on the next slide, but I'm kicking open an open door, or kicking in an open door over here. Of course, our purpose is to offload as much possible computational power to the edge. If we go to the next slide, the reason for that is fairly simple, because we want to leverage the scalability of edge infrastructures. On the next slide, Barbara.
What do you see now? Because there might be some delay.
I still see the 5G autonomy as a service slide.
Okay.
I'm not going to go in detail into that because this is about offloading computational power, but I want to go into the next slide on what the benefits are also, legislation-wise, quality of service-wise, data sensitivity and safety-wise. Yeah. We didn't implement all these features yet. We already touched upon it. One of the things that will be important in the future will be network slicing, but it will allow us to really segregate between time-sensitive applications and mission-critical applications, as well as the data-sensitive applications, and maybe even legislation-sensitive applications, such as UTM integration, identification of the drone, etc. It creates also benefits around security and data privacy. And basically, we leverage there the offloading of the data processing and AI. We can offload some of the navigation skills, not to the lowest level. Yeah, we always have some intelligence sitting on top of the drone too, but really creating a bigger context for more optimized navigation can only happen in a centralized way. Image recognition, object recognition, etc. Yeah, there are many features that can be offloaded and which will be important for the scalability of these solutions. Now, going to the next slide, yeah, I think we touch upon one of maybe the most important differences that we noticed. Yeah, as mentioned also, from our approach, we are using in the backend a lot of the robotics, by the way, not only us in the ecosystem, we are well embedded in that ecosystem. So many operators that are using robots will leverage in one way or another ROS. Yeah, either a ROS2 or a ROS2, a ROS1 or a ROS2 variation. ROS1 is less mature, I would say, and also not that scalable. It's more an R&D platform, while ROS2 is really being created already to be more scalable. That means that it also leverages some communication standards, in this case DDS. And although it provides you with some nice features that come out of the box, it also includes a layer of challenge that is being introduced to that. A layer of challenge that maybe we as service providers are not fully experts in, yeah, but we have to manage it to a certain extent. And at the same time, it will push for certain requirements on the telco and the network side of things. And we bumped into some challenges over there. What it provides, of course, is we can make use of the distributed discovery, serialization, the transportation of data. We can leverage some protocols for different quality of services, and we can configure that, and we can tune that. As mentioned, that is already a challenge on our side. So we are looking in the ecosystem on our side to have experts supporting us on that. That's number one. But one of the requirements we have over there is that the peer-to-peer communication is very important. And one of the first solutions as a startup was, okay, if we are working on a network that is public and we have to deal with netting, the fastest way to overcome this challenge is to grab and take a VPN and install a VPN. It's a solution that would work, but of course you increase on top of the layer of DDS another layer of dependency. I think that was one of the biggest battles we have fought, not with each other, us and Telefonica, but with the ecosystem on finding how we can overcome some of the challenges with using a VPN, also challenging whether the use of a VPN is a correct approach for our solutions. And we always take a critical view. And still today, we are looking into that. We are still evaluating how we can minimize the impact and the liability and dependencies on third-party platforms for our end-to-end solution. Yeah, the more we can minimize that to our service and the network layer, the better it is, and the more control we will have over that. So that's one of the things we are working on. And we've noticed that ROS adds on a lot of value. But we need to evaluate how we need to package that and how we can make it, let's say, robust, maintainable, and scalable for the future. So one of these things is that indeed it could not work with NAT. I talked about it. Peer-to-peer communication we cannot get. Port usage is not following the GC-NAT rules, and then addressing of other peers need to be discovered. And if that discovery is not happening properly in the first phase, then you will not see your device. It will not be onboarded, and you have a problem to deploy your solution. If we go to the next slide. This is a bit of an overview of how the DDS works. I'm not going to go too much in detail. This is an open standard. All the documentation is available online, as well as for ROS in that ecosystem. It's not unknown because NASA is using it too. AWS is using this, Bosch, Google. There's a lot of companies that are adopting it. So that ecosystem is maturing, but also not there yet. So it's still a bit of a liability. It does allow us to transmit and adjust the change of the behavior of the data that we transmit. For telemetry information, we did notice that it was less reliable for telemetry information, but more reliable for our mission control side of things. Yeah, we could really guarantee and confirm that the data arrived. Now, so far DDS, if we go to the next slide, and I'm almost concluding here because I see I ran out of time, is if you look at the benefits of challenges, I made 2 slides around that. One was really on what we have learned in this trajectory and these collaborations also with Telefonica, which are really applicable here. And some of them will be complementary to what David said. Some of them will be overlapping. And then I will have a slide also on the more generic one, what we see in the ecosystem, which will be insightful maybe also for all of you. So if you look at the benefit side, again, we really see the benefits and the added value of edge computing together with 5G. We have confirmed that in different deployments, we just need to work on the reliability and the availability and ensuring that quality of service is there on one side, but also from our side as a service provider, we need to make sure that if that service or that quality of service is not there, that we have the correct mechanisms in place to counteract on that or to deal with that. So it's on 2 sides. We also looked into routing the traffic to the nearest location to provide the best communication, which will be one of the benefits. So we can always run on the closest infrastructure to ensure the lowest latency and the highest quality of service. As already mentioned by David, working on these APIs will give us a lot of benefit and insights also in the network that we have, but also other insights and maybe accessibility to 5G capabilities where we can in the future ask for a certain quality of service in a certain location at a certain time. Yeah, today that is not feasible yet, but these are things that in the future could be opened up and could help us for the deployment of use cases in the field. And then finally, also operators could then also provide us with private APNs to work in a more secured environment. You saw with David, there are different deployments that we could do. Of course, our goal is to be compatible with all of them and to have it plug and play, that the onboarding goes plug and play. We still have some work to do over there based on the key learnings. Some of the challenges was the 5G deployment. Again, we are learning over there, as mentioned. We didn't have the coverage on all the altitudes, which was also, again, difficult to explore because is it then, again, a software issue? Is it a network issue? Now we are also working on our side on some visualization around that so that the operator can see what is happening in the backend. So there we are also maturing as a company. Secondary, I would like to say over here too, that we as a company took a strategical decision over here in close collaboration with Telefonica to actually also hire internally people with more telco background. And I think that is also a very valuable outcome of this collaboration and the GSMA Foundry that which is paying off today on a day-to-day basis, that we collaborate now with some telco knowledge inside our company. And you see the same movement is happening also on Telefonica side, where they have some people that are more have more expertise and know-how in the drone space. So we are bringing these 2 worlds really together by also adjusting strategically how we hire and who we hire, which is very important. Yeah? We are also looking into better, or we had some issues with the antennas and the modules, the modems that we could use. As I said, we went from phones to ZXL MIMOs with Ethernet background backhauls or Wi-Fi backhauls. And now we are using modems that slot into the PCIe slot of the onboard computers. We are still trying to optimize the antenna setups over there, again in collaboration with Telefonica. We looked into cloud deployments, yeah, so that we can improve the support in the future for the container orchestration. Telco edge computing can also offer us some the set of APIs as mentioned, but that was also one of the challenges we still faced during these collaborations. And then on the modem side, we have now access to smaller modems that can be installed on board, but we do still see that there are still, let's say, bugs or limitations on the configuration of these devices. So there we will need some support of the ecosystem and of the suppliers and the providers also. And then the final slide is a generic overview of some challenges, which is network coverage. We touched upon that already. Yeah. So I think monitoring and visualization will be important, as well as improving the network for aerial devices. Secondary, although we worked here on public networks, we do see with other projects that sometimes we have to work on private networks, sometimes on public networks. And often one of the biggest challenges is working on a hybrid setup where some of the data is on a public infrastructure, for example, the machine learning, the AI, more centralized. And then on site, you have your deployment, your orchestrator, which is only using the AI as an input. And then having a tunnel between your public and your private network in a safe and secure way. So that's something that is also interesting to look into. And we've bumped into these restrictions already during projects. The device interaction, how we can leverage 5G and edge computing when different devices are being interacting in a close manner, and also visualizing that. Edge mobility is not a problem yet now, but once drones are starting being used for delivery, they will do longer distances, and they might have to dynamically switch between different edge infrastructures. We have worked already on some client SDKs. We have proven that we can onboard on the closest infrastructure, but there are for sure still challenges where what are we going to do with the data during the handover? How are we going to manage that? So there are still some problems we'll have to overcome in the future over there. Prioritization, this will come with the slicing also. As I mentioned, the quality of service and mission critical layers will need to be enabled. And then finally, I think a very important one, but not a technical one directly, is the legislation. We as a company, we are working also closely together with the legislation and the authorities. We try to involve them in every deployment we do to educate them as much as we can to get waivers and approvals. And what we do see, and I want to share with everybody on the call, is that there is a bit of a movement happening where a lot of people are allowing private airspaces, sandboxes. I think Telefonica can be compared with that. Their headquarters, their campus is a bit of a sandbox where we can fly within, where we have, let's say, the permits and the waivers under the control of Telefonica. And we see the same movement happening in ports, in big manufacturing plants, such as automotive industry, where they create their own airspaces around it, and they can perform tests, flights on a more commercial scale within these sandboxes. And that allows to test the technology, to improve the technology, but also to educate legislation and optimize the legislation towards the future. So I think one of the first steps to commercially roll it out will be more these private sandboxes and networks and infrastructures, as well as airspaces, and then moving towards more public rollout once these technologies are fully confirmed and validated. That's it from my side. Apologies, I took a little bit more time, but I appreciate your patience.
No worries, you're welcome. So I guess now we can take some of the questions. So I saw there are quite a few questions on the chat. Let me stop sharing the screen. If I can go back maybe to the beginning, there's quite a few questions for you, David, also. Let's see if the first one was, did you have to modify an orientation for the scenarios you indicated?
No, we didn't. We didn't change anything, so it was the other way around. We need to adapt certain elements of the use cases to the existing conditions.
Perfect. Then Alexander asked, any requirement related to location accuracy, precise position? So obviously you mentioned that you had to do some work, but do you have a specific requirements? How did you pick and choose what was good enough, so to say?
Yeah,
Alexander, if you want to say something, I see your hands up.
Maybe you want to contribute something, Alexander, on that question.
No, go ahead, Kim. I may clarify that afterwards.
Perfect. I think on the outdoor use case, it's fairly straightforward because you use over there and leverage the existing, as I said, the triple redundant system for localization with GPS. And even the DJI platform, for example, has these cameras built in. So you have those safety mechanisms built in. Plus, during landing, you have ground-facing cameras that will check if the ground is even, level, and if there is enough area to land. Otherwise, it will not land, and you need to take manually the control of the drone to land on another location. So there's not so much a dependency. If you talk about indoors, in the area that we have to fly, you basically want to obtain an accuracy of about 10 centimeter accurate, plus minus. And that is very challenging to achieve, especially if we put the extra challenge over there of saying, okay, no absolute reference system. Let's try to do it fully on board of the drone. And we went really fully extreme on that with using one camera on the drone to do that localization. That was quite a challenge. That was really challenging. We tried also to see computational power if we onboard that, if we offboard that. We learned over there that for these kind of applications, a lot of it is still computed on board to do the point cloud, let's say, and then the location is offloaded to the edge for the context. in this case. And we did learn also that adding on a secondary and a third localization helps in the robustness of the setup. Yeah, as well as references, making sure there's not much repetition. And yes, it's fundamentally important. And keep in mind, this is only one drone for the indoor use case now. Imagine that you're collaborating over there with a ground vehicle or with 2 drones that need to fly in the same airspace. It is only going to become more important. I have been looking into and talking with different partners in the, let's say, in the research ecosystem, and how we could leverage in the future also localization from 5G. Yeah, because they also can provide us with a localization via an API. It's not fully available yet. That's one. In R&D, you can get access to it, but then the accuracy is meters. And for our solutions, that's not accurate and precise enough to deploy it on. It's good for asset tracking to know where they are in a specific environment, but not yet for the real localization of the device for orchestration and control and command.
Thank you, Kim. I think you explained to the auditorium most of what is viable in the circumstances of the warehouse or so. And I know those drones have to be very small, light. Yeah. For example, in the areas where you have mining tunnels or similars, this is where some of the DSLAM would have to be used. Those are relatively heavy cameras to put on a light version of the drone. So maybe if we can have an industry push for miniaturization of the DSLAM cameras, might be a way to take. And it's one of the probably next hot topics for the aerial drones is how do you optimize these they call it CNS, like communication, navigation, and sensing. So try to address as much as possible those things through what the seller ecosystem brings on a table, rather than running a bunch of technologies that don't really integrate with each others. But you've taken a very creative approach here. I actually had personally opportunity to see that in action, and it's a way to go. One note for the RTK. RTK is to some extent left to the local authorities to deploy. So by having an RTK capability on a drone only does not necessarily mean you're going to have it in, let's say, middle of nowhere in Canada, where I'm from, versus somewhere where regulators took the much more serious approach, like in England, and give it to Vodafone's or Siemens of the world to actually deploy it on behalf of the governmental entity to regulate the precision of those. Thanks, Kim and David, fantastic presentations.
Thank you. So there's the next question is from Ed, which I believe actually had to leave, but was about was the peer-to-peer in cellular or the other frequencies for detect and avoid or for cooperation? I guess it was for the command and control. Then
it's actually in general, because all the data is flowing through, in that case, the DDS protocol that we were using. So no matter if it was for detect and avoid, to be honest, detect and avoid is something that we typically keep on the drone itself. So there's 2 levels here. You have the reactive. The detect and avoid for me is reactive. It's not something that we need to have with a closed loop over a wireless network. It's something that you want to embed on the drone. It's a safety mechanism that needs to be embedded. And we have 2 of them over there. I said we have the flight control unit, which will do that itself. And then we'll have our software on top of the device. And then, of course, we try to avoid these interactions. So there is a feed-forward system in the swarm control where, if we know the trajectory of different devices, we can manage them in such a way that there is no collision or no interaction between the devices. So first of all, you try to do it feed forward and to avoid these interactions. But in case it happens, or there's a foreign object that you cannot anticipate on, you of course have detect and avoid, and then that is on board of the device. You don't want to rely on legislation will never allow that also. They will always expect a certain minimum self-sustained level on the device itself.
Thank you. I guess you already answered this one, but if you want to go over, is where is the edge platform deployed?
Yeah, in the public network, we are using 3 locations in the 5G use case lab: Madrid, Barcelona, and Sevilla in Spain. And for this use case, for the, let's say, exploitation, we were using the one in Madrid. But also we are using the Barcelona node for Unmanned Life because they have an office there for the testing and optimization.
Thank you. Then there's a question from Gutpa. Is the mission control related communication in the example? I believe it covers command and control, plus other non-UAV control communication, like controlling the camera, the movement, orientation. Would be good to understand where they use in the same PDU session, connection or separate one, if they need to benefit to use separate PDU session or PDN connections.
Everything is using the same APN. I mean, all the streams of data are using the same APN, so it's using the same PDN session. But it is true that, as I mentioned in the presentation, we are checking and taking a look to what will be the optimizations that we could have. So ideally, we need to separate the mission control traffic from the video streaming, for instance, because of the characteristics that those two would have. And ideally, we could use the same PDN session, but maybe with different betters. So we could adapt the QoS specifically for each one of the betters. So we will use maybe two betters, one for the control, for the mission control, and another one for the video streaming. Or if we take this farther to the slices, maybe we need to have separate slices, configured for these traffics. But I would definitely go for separation.
Obviously, this is one of the difference between 4G and 5G. So 4G is only one PDN, one bearer, but in 5G you can have multiple bearer, multiple QoS flows. So you can separate having the same PDN session, I guess. I guess you guys are already using that system.
Well, in 4G, maybe we could, that's something that we need to check. And also it's important the support of the devices, but maybe it would be possible also to separate in the same PDN session two different betters, like we do, for instance, for the voice traffic, for the IMS APNs. That is something that we are investigating, but definitely slicing is only going to be available in 5G, exactly.
Okay, thank you for that. Should the indoor use BLE beacons instead of GPS? You mentioned before, yeah.
Yeah, I referred to that. So the bottom line is always the more systems you have redundant and in parallel, the more robust it is. That's for sure. And it's always good to have a combination of absolute and relative positioning combined. So you can compensate for the drift, but then in cases that you don't have an absolute reference because of no line of sight or other interferences, you can still rely on a relative positioning system. So we typically try to combine it. One of the solutions that we're looking into for the future also for like indoor warehousing is these warehouses can be very big. So installing a full infrastructure can be quite invasive, financially costly. So typically we try to be the least invasive as possible. So we took now the extreme of no absolute reference system, but it could be that there is a middle ground because we orchestrate different devices. You could have a mobile device because ground robots, they typically have a much easier way of localizing. They can use SLAM. They can use maps. You can put a blueprint in there, so they can have centimeter accurate localization, very stable and robust, high battery autonomy. And if you combine that with an AMR with a reference as a beacon together with a drone, you could get a mobile absolute reference point in a warehouse. These are things we didn't roll out yet, but we know the technology and the building blocks are available. So it's a matter of developing, testing, and then deploying it at scale at some point.
Thank you for that. Then there is a Jarno that has a question, but more the question is actually they're looking for a telco partner to work with that. But I leave it to you and to our conversation with Jarno.
We'll follow up on that.
Shaheen, what is the applicable fee? So I don't know if you is this already like a commercial or is still on pre-commercial? I don't know if you can say something about which phases are you or during the the commercialization of the services. Yeah, so maybe David, you want to go? I can from my side also, because I think we both have some challenges on each side to overcome. I think from a technology side, there is for us, of course, you come from, especially as a startup, you come from a background where you first do proof of concept demonstrations, pilots, trials, and so on. You learn a lot from them, you steer that. We have made that shift now to certain product lines. Surveillance is one of them, search and rescue another one, ad hoc supply chain. So there's a few that we are focusing on, made on the same building blocks underneath. And then to bring it, is there a fee? At least from our side, some of the challenge is still the robustness and maturity to lift that up and add on features on that side.
And then on the other side, on how at least we bring it to the customer, and some of these are in collaboration with Telefonica too. These demonstration kits in the first place are already part of that selling package, because it allows now Telefonica at any time, without having to rely on Unmanned Life, to deploy and showcase that combination and an end-to-end solution, both indoors as well as outdoors. I think that is a huge benefit already. It's also a great key learning for us to see if a third party is working with your application. It's a little bit giving your baby away. After a few years, you took care of it all the time, and suddenly you hand it over and you trust it to a third party, and that doesn't always go smoothly. And we learn from that too. Sometimes we overestimate or underestimate the knowledge of the counterparty, and not in a bad way. It's just what it is, different fields of expertise again. And that was harsh for us in the beginning. Also, we learned over there that providing support for a startup company can be very challenging. Yeah, you have a lot of things that you're juggling at the same time. So how can you want to provide a good service to your partner? At the same time, you have a lot of other people pulling your sleeve. So also that balance we are working on. So increasing team capacity, variation of the profiles we have. And then finally, on the fee side, we typically deploy with a kind of 3-layer model on our side. One is a one-time setup fee, depending on the deployment we need to do, because there is some installation required, commissioning, preparations. And then there's 2 models over there that are sitting on top. One is the platform license, which is really providing you the maintenance, support, upgrades of the firmware, and general support on the platform. And then you pay per deployed device. So if you're deploying 1 to 25 devices, you pay a certain fee per device that you deploy. And then the price goes down depending on the number you deploy beyond that. So it's a 3-layered approach: one-time setup fee, platform license annually, and then payment per device.
Yeah, well, maybe to complement in our case, our business, in the case of Telefonica, I mean, the target will be to offer this as services as well as a service. But due to the maturity and the challenges of these scenarios with regulation and technology, it is clear that we are going to start with turnkey projects with customers, where we do the full things.
Understood. Thank you for that. Another question from Alexander is about if you had any consideration to deploy Unmanned Life AIS behind the NAF or the SCAF, I guess NAF or 5G mobile packet core by leveraging the CAP IF.
Yeah, maybe I can.
Yeah, maybe it's much for Kim, but for you, David.
I think this is one of these examples where I think David, from a network perspective, is better placed than me in this case.
And that was a question for him actually,
yes,
because you at the end of the day want to have an easy settled interface and smooth integration. Kim, go ahead.
Yeah, well, maybe I will use GSMA terminology. We don't see any application partner, any third party consuming a NEF or a SCAF API directly. So for that, for instance, there are 2 possibilities that I guess we as operator, as Telefonica, but in general, the industry are considering, right? So the first one and the simplest one is the integration of the telco edge with the NEF, which is something that we have trialed. We've been doing several POCs already on that direction. So it means that for Kim and Unmanned Life will be very simple, because they will deploy on the telco edge platform the application load, and as one of the parameters they will request which is the QoS they want from the network, right? And the telco edge will be in touch with the NEF to request this accordingly, and other parameters as well, right, of the deployment. And there's other options, like for instance, provide to the application partner more control about the connectivity using an API, and for that we will normally expose a Camara API, like the QoS on demand API, from the operator platform exposing NAS capabilities. So this is more or less the vision that we are working towards.
Thank you for that. So then I think we'll go to Jyrki. Thanks for the excellent presentation. Understanding the focus was to study the edge expert. Did you explore or note impact on the variation of radio performances within campus fly area of the drones? I think you mentioned that you noticed some differences.
Yeah.
I
don't know,
Kim, was very insightful. Yeah, because actually we discussed this beforehand also with Telefonica, and there were RF tests, there were tests conducted. We had a map also with the coverage area. The colleagues of David have done an extensive work on that with mapping that out. But nonetheless, once you start flying, one of the first issues we did bump into was that dynamic handshaking then between a 4G network, 5G network. And yeah, initially we were a little bit blind on that because we didn't have any measurements around it. We had no logging system around it to monitor exactly what was happening on a network layer. And I think that's one of the things that we have been working on because it's not a problem to have it, but it's important to identify it in the first place. A first step could be to at least share it with the user that there is handshaking happening. So if the video feed would freeze or the quality would change or it would have some buffering, it could be that it is network that is handshaking. And if you know that, you have a pop-up that is already okay, you could take peace with that. And then secondary towards the future via the APIs, it will be interesting to optimize that network for specific drone corridors in specific locations. I see, especially in the near future, a combination in an ecosystem where we will be working on both networks. There will be 4G and 5G. It will be complementary. But we will have areas where it is more rural, more dense, where we will leverage the benefits of 5G because it will be a more complex environment. We will have to interact, we'll have to land, take off. And then you will be roaming between point A and point B, where you can use highways and corridors for drones, where you will have less requirements and dependencies on quality of service, latency, and bandwidth during those processes. Yeah, I see that combination happening in the future.
Yeah, thank you for that. So as a GSMA, we do ACJ, we do try to do a lot of work, particularly on that network information. So hopefully it's going to be useful for all DMNO. There's another question from Alexander from direct to UE communication. Would be ideal MNO's capability to have for the, I guess, you mean unmanned life requirements?
Yes.
Yeah, but it is true that there is no direct communication between drones, right, Kim? So
no, at this moment we don't use it. I know where the question with Alexander comes from also, because I know with TELUS we are working with some IoT SIM cards over there, M2M SIM cards. So they would allow us to indeed have that machine-to-machine communication also. However, today, as we are still orchestrating everything centralized and the scale we are deploying at, we didn't explore that yet. Yeah, so it's not that I can already set out requirements over there. We did discuss it already internally, and once we start scaling up, there are potentially some benefits of having direct machine-to-machine communication instead of uploading everything to the edge infrastructure. But today we are not leveraging it yet. As such, we are also not having any insights yet in it, unfortunately. But
yeah, this was more of a kind of a potential direction to explore, rather than a comment. And I think we own one clarification, Kim, is you're trying to set up your whole system, including the mission controller, including the drone or robot, and any type of the backend systems, that they're all kind of enabled through cellular connectivity. So these UEs are actually sitting across any of those components, not just on a drone. That's something that I'm not sure if Auditorio was able to pick up so far.
Thank you for that, Alexander. There is a question, actually, a more clarification that John Heave would like to get back to. One question from Matt is the P2P answer from the ad question, I think it was about the cooperations, can you confirm if it's used for the cooperation or not?
So if I understand the question correctly, is if we collaborate between different devices, everything is communicated today over the cellular network. Yeah, so you need to see it as a kind of a star deployment, a system of systems. You have at the center of the system of systems our ULCCP, the central control platform, and then each device is at all times connected and relate with that central control platform. So we always have let's say in this case, a vehicle to edge communication to control it. That's where we create also the central context. And then from there, we can steer and orchestrate the devices again. So that communication is important. Of course, today, if you lose the connectivity, the device that loses the connectivity is not part of the swarm anymore. It's a standalone unit. It's still self-sustained. As I said, we have a brain on top of the drone too, which is limited in capabilities, but can still land the drone, return to home. It can continue the mission if the use case allows it and the environment allows it. So we can configure that depending on the requirements today.
Maybe
if I may, Barbara.
Yes, exactly.
This is Shahid. Thank you, Kim. I believe that from the previous discussion from Alexander question regarding future use of UE to UE, it's clear that even for corporation, there's no UE to UE or P2P at the moment, but maybe in the future. But thank you for clarification.
No worries. There are some, next to orchestration, just to share that there are some interesting features that could be enabled with vehicle-to-vehicle communication also. One is, we talked about it, collision avoidance could not only be sense and react, but it could be communicate and react, for example. Another one is that there are some algorithms out there that next to RTK localization, you could leverage communication between vehicles, create a mesh communication, and actually compute a more precise and more accurate location of each device, at least in relation to each other and in relation maybe to the ground station. So there are features that could be added on an individual scale based on machine-to-machine communication, indeed.
Okay, many thanks.
Yes, I can imagine that actually that would be the V2V communication very useful when you have, maybe it's not your case, a sworn like the drone show, instead of using GPS and a relative, you know, you can still use a relative location.
There are universities and research programs that really work on that hive formation and that take that approach. Because a lot of our use cases are more commercial, robustness and reliability is key. So in our strategy, it's very important. We can do much more also on autonomy than what we do today, but you need to keep it under a certain control. And although it's autonomous, you still know the variations that can happen. We don't open that up fully. It's a bit like with autonomous cars too. They are not fully autonomous on the road. They are taking tiers and stages. It's a bit similar over here. And our customers today and our partners want to have mainly the robustness and reliability in the first place. And then over time, we will be adding on features. So we take that in a structural and well-defined approach. Yeah.
Thank you for that. I guess with this one, I finished all the questions. Maybe one final question to both of you. We've seen your next phases, what you want to do next, the challenges that are still, to be solved. What is the timeline you're thinking about, for example, to do some tests on? You mentioned, for example, the network slicing or the 5G SA, because it's kind of commercial in different in the coming year. What would be your next, let's say, next immediate step that you're thinking of?
Yeah, well, at least from our perspective, we are really focused on this 2E architecture that we mentioned and bringing all the components to the public network edge. This is the most immediate one, and we expect to do it across the following year, months this year. This is the most immediate one, and I don't think that we are going to test slicing this year. Maybe that's something that will be available in the 5 use case lab next year. We have environments for testing, but again, as we want to test it over production, I think it's wise to wait for next year.
Yeah, it's very much in line with that. We are also prioritizing over there, and then slicing, it will be very important in the future. We also need to look at the current state of affairs, so the scalability that these solutions are being deployed. It's something that we would be ahead of time if we would be doing it now. We would be ready for it, but would be ahead of time. So there are some other challenges we need to tackle first. And we are continuously engaging with Telefonica and with their team to still improve on our side. Also, when we talked about the architecture-wise, some of these fundamental decisions on ROS, DDS, the VPN, we are still discussing that. So on our side, we are exploring, and it's a bit complex for us to do that because we are as well communicating with the different industry experts on the robotics side to see what is happening over there. We're trying to translate that to our needs and demands. And at the same time, we're trying to combine that all together and discuss that with not only Telefonica, but for example, also with Alexander from Thales here on the call and some other partners we are working with, because we want to have it as generic as possible, of course. At the end, it should not be a burden to install a new application. The onboarding should go seamless. That is really the goal. And that's something that we still have some work to do on, and where these partnerships and collaborations are really important. They can be hard, again, as a startup, to have the resources available everywhere, but they are fundamentally important. So we do need to pay attention to that. And we are looking now also in increasing the team already. As I said, we hired an expert in the field of telecommunication and networking and cloud and edge. And we are already looking into supporting that person because we see what high value and return we get out of these profiles. So that is really good. And also good of the support we got from Telefonica, because they helped us to direct us in the correct direction with the profiles that would be perfectly tailored for this. And this also helped us. So for us, this is a very important outcome of this partnership.
Thank you for that. And with this, I also want to thank you, because as a GSMA, we worked in defining the profile for LTE, but you guys are actually already, working on a 5G. So the next step that we will do is mapping the quality of services that are required on 5G. So we will need your input on give us feedback on what it makes sense to go to the next level. With this one, if there are no more any more questions, so I want to thank you for the time. It's been very useful. Just want to remind it all that the recording will be available. Just give us, let's say, maybe a week to do all the editing, the cleaning. Will be available on our website. I will inform you all when these are available. Alexander, if you want to just say thank you from your side.
Yeah, on behalf of GSMA Drone Interest Group, I have been a couple of days ago asked to help in a chairing capacity. I want to thank both David and Kim for a wonderful presentation today. I'm pretty sure at some point in time when you uncover the lessons for the bullet points that are kind of ahead of you in evolution path, we're going to be in a position to regroup and hear the updates from your side. Barbara, there was a comment from Genevieve, if we can give also decks, not just the call recording in a place. So that's just...
I think it should be fine. I just check maybe with David and Kim if you are okay with that. We can also do the PDF and share with the participants.
Yeah, I'm okay from my side, Barbara. Yeah.
Thank you for that. So yes, we'll do that, Genevieve.
Thank you again, both for your time, and I'll leave it to Barbara to conclude. Thank you.
No, thank you very much. That was all. Again, hopefully we're gonna have another interesting session. So we don't have it yet planned, but please keep posted. Thank you again for the session and for your time, David and Kim. Thank you very much.
Thanks for the opportunity.
Yeah, likewise. Thanks for organizing this all. Appreciate it.
Thank you.
Bye-bye.
Bye. Have a nice day.